Welcome back to Advent of Code 2025, Day 5, Cafeteria. As the forklifts break through the wall, the elves are delighted to discover that there was a cafeteria on the other side after all. You can hear a commotion coming from the kitchen. At this rate, we won't have any time left to put the wreaths up in the dining hall. Resolute in your quest, you investigate. If only we hadn't switched to the new inventory management system right before Christmas. Another elf exclaims. You ask what's going on. The elves in the kitchen explain the situation. Because of their complicated new inventory management system, they can't figure out which of their ingredients are fresh and which are spoiled. When you ask how it works, give you a copy of the database, your puzzle input. The database operates on ingredient IDs. It consists of a list of fresh ingredient ID ranges, a blank line, and a list of available ingredient IDs. For example, 35, 1014, 1620, 1218, 158, blah. The fresh ID ranges are inclusive. So 3, 4, 5 are all fresh. The ranges also overlap. The elves are trying to determine which of the available ingredient IDs are fresh. In this example, this is done as follows. 1 is spoiled. It's not right. 5 is fresh. Okay. So 3 of the available IDs are fresh. So the IDs are on the bottom and the ranges are here. We check how many are in a range. How many ingredients are fresh? Okay. Let's try that. So we go we can make a mutable list of int ranges and mutable list of int. And then I go for each line. So if the line contains minus, the range, so I can say fresh dot add let's pass the line. Line dot split 0. We add that. The line contains no, it doesn't really contain anything. It just has a size or length. Then line dot to int. Line is not empty. Check if it works. So we have 3 to 5, 10 to 14, and so on. Okay. Now we just have to go ingredients for each. Result is 0 if it let's say ingredient in any ingredient in it, then we count. So then we have the result 3. Okay, that's it. So we have 3 ingredients. Then we have a puzzle input. Oh, these are really big. I think they need to be longs actually. Let's do 2 long. Yeah. This, now we have long range. Doesn't exist. Ingredient also needs to be long. Oops. What else? Let's try that. And we have 821. And that's correct. The elves are bringing their spoiled inventory to the trash chute at the back of the kitchen. So they can stop bugging you when they get new inventory. The elves would like to know all of the IDs that the fresh ingredient ID range is considered to be fresh. An ingredient ID is still considered fresh if it's in any range. Now the second section of the database is irrelevant. Here are the fresh ingredient from the above example. How many ingredient IDs are considered to be fresh according to the fresh ingredient ID ranges? Oh, okay. So we need to get back to our simple example. So we can count, right? 3, 4, 5, 10, 11, 12, 13, 14, 16, 17, 20, but also 12 to 18. And these overlap a bit. So this is more like 1. 1 range from 10 to 20. Yeah, let's just try. So we have ingredients. No, we have fresh. Well, let's just rename fresh to ranges. We have our ranges. I think we need to sort, I think. Then we have 10, 12, and 16. Maybe like this. Okay, we have this. Okay, 10, 12, and then 60. Maybe we can build overlapping ones. Maybe we can just go through the list and try to combine them. Fun, try, combine. Ranges in the list of long range. So then we go. Okay, maybe we can put ranges in here. Sorted here. Can we do like two things or something? I always forget how that works. Hmm. 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 Last, I guess, not second. It does work then. Hmm. Something like this. Does it expect an int? Hmm. Okay, whatever. Let's just see if it's maybe enough to have just sort by first. Or we can check actually. Let's go here. Let me check. We just print it and then we just do. Damn it, there are different ones. Okay, we do have to figure out the sorting. Okay. Check that there are some ranges here. Start with the same number. Or maybe we don't have to sort. We can just go pick the one with the largest one. We can just go through. Pick the one with the largest. Okay, we can do this outside. Limited ranges. Okay, we need something like map. Oh, we do group. We don't even have to sort. We just do group by first map. So we have key and value, right? And then we just say key to maybe just like this. Last. And then we can check these guys. So what I'm doing is I take the ranges, I group by the first one in the range, then I map the last, the largest one of the ones that start with one number, take the largest one, and then I have limited range, and then I can check again. We should have the same ones here now. Okay, this doesn't work. Yes, so it's 165, right? So then we can put this in a method. Keep largest by second, by last, by range, and then I would say we should do that every time. No, I think we're fine now. We only have to do it once. Okay, what's this? Okay. We wanna, or just values, or what? List of pair? Yeah, we just want the, I want a list of long range. Okay, so then we can try to combine them. So if we have a simple input, maybe we have 12, 19 here. Now I can say limited ranges only has 12, 19, so we got rid of 12, 18 because we don't really need 12, 18. And now we have a list that's sorted by the first, so the first element in each int range. And there's only one always, so then we can just go through and see, can we combine? Also, it's always sorted now. So we don't have to sort again, I'll just leave it in. Let's try it out, let's see what happens. Ranges dot for each one we go maybe drop one. Oh, why does that not work? Or maybe I can like drop the last one here. And then I go if I will compare the last ones. Is the last one greater or equal? And then the next one's last one. Then I should combine it. Hmm. I can just return also. Oops. I can just return early here. I find one. I just get rid of it, right? What do I do? So in this example, we have this example. You just keep the first one and the last one. So we drop I plus 1, remove add or something. Can I remove? Uh, remove at I plus 1. new, while result is remove at I plus 1. Okay, wait. Result is this. Then we have the removed one. Then we go to I. Okay, I is int range from first to remove the last. Okay, this will be long range. And we return result. Then we can say see if combined dot size is smaller than limited ranges dot size. Then we want to continue. So if it's thing and done is true. Let's make a var. Put this here. And then also combined is always updated. Not good. New combined. So if new combined is we update it and then we go yeah, print combined. Let's see if this works for our case. So we have 10 to 14 and 16 to 19. That's pretty bad. So what did it do? We definitely, let's just see which one again. In ranges, and this is combined. Okay, so we get rid of 12 to 18 here. We have only 12 to 19 left. Somehow it's not sorted. I would have assumed it's sorted. Maybe we should just sort it here. Kind of important. Okay. Then we have these, okay. And then combined is the same. So it's not doing anything. Okay, let's try to combine again. Let's see what if. You have to check if, let's say 14 is greater or equal to 12. Then we combine them. Let's try this. Okay. So now we have left 3 to 5. Then we have 10 to 14. We combine with this, which is 10 to 19. Then we combine with this with 10 to 20. That's what I wanted. Okay, perfectly. Perfect. So now we can say map it dot last minus it dot first. So if I have 3 to 5, then that should be 3. So 3, 4, 5. It should be 3, which is kind of like 5 minus 3 and plus 1. So we go plus 1 here. And then sum it. Let's say this is a distances. We can do this. 14. And that's 14. There we go. And then we can try with the big list. See what we get. It's a big number. And that's too low. Wow, that's fascinating. Um, let's look at the sizes. Look at this, and then we look at this. Okay, we have 187 range, and then we have 165 after we always pick the largest one for each starting one. Mm, okay. Yeah, that should work fine. Combined is 93, so then vielleicht kann ich auch, could I print the removed one? Similar ones here. Maybe I should sort it again. I don't think I need to sort it again. Hundred 65. Mm-hmm. I know what I could do. I could check if it's valid. So let's confirm. Mhm. I mean, just try keep this for combine. Oh, It's the same. Okay, that doesn't do anything. That's good. So everyone has distinct start day, start numbers. And oh, actually, no, first it's smaller always, right? What happens if I have 1, 3, or 1, 4, 6, 2, 8? Okay, that doesn't matter. 1 to 4, 4 to 7, then I can update it. Remove that last. And I should, otherwise I double count, but I'm somehow not counting enough. Hmm. Still fresh if it's in any range. Hmm. What are the differences? Hmm. It was 1 first. Uh, print that. See what happens. Okay, so they're quite big. Sometimes a 2. Sometimes there's a 1. Hmm. Hmm. I wonder if it's weird if they're touching us. Um, D. Okay, now let's see. So here we have this. Ah, it only goes one. And then here, this one's bigger. Hmm. Oh, I know that's the same one that by design. That's fine. Maybe not anything can go wrong with this sorting or the keeping. Maybe I should always keep it. Try that. I don't really know why it needs to have mutable list. They get the same number. Hmm. No, it doesn't make a difference. Hmm. Okay, I wrote down some examples and realized something. So, if I have 1 to 4, 6 to 7, then I keep it in. 1 to 4, 5 to 7, I can also keep it in, doesn't matter. And in this example, when the last one of the current one is greater than the first one of the second one, we would update it to take the first one here and take the removed last's highest number, but then we could end up with a smaller range than this range. So basically, if the second one completely contains this, then what we want is this here. So I think we need maximum of result last. Oops. And in the other case, what we already checked, so we have 2 to 6 or 7. Maybe we just get 1 to 7. That works. So let's run this. And then we should have a bigger number. Yeah. Okay, so that's day 5. So for part 1, we just want to check these int ranges, which of these numbers is in there. So it's easy to just check all of them. But what we did is we get the ranges by parsing all of the lines that have this 2 numbers. And then we get the ingredients by parsing all the lines that have 1 number. So if the line contains 2 numbers, I add it to my ranges. If it's 1 number, I add the ingredients. Then for each ingredient, I check does any range contain it, increase my counter, and then that's the result for part 1. For part 2, we need to check, regardless of any ingredient list, how many numbers are in these ranges. And the problem is that ranges can overlap. So what we want to do is get a distinct list of ranges that don't overlap, and then we can easily just count, because we know in this range there's 18 minus 12 plus 1 element, so there's 7 elements in here. So if we have distinct ranges, we can just count it easily. So first have to get distinct ranges. So the first thing we do is we sort it by, we go through these ranges. So ranges have a first and a last element. Then I sort by the first one, group by the first one. Then for each ranges that have the same first, I take the largest last one and only keep that. And then I only keep the list of long ranges after my grouping. And mapping is done, I don't need the groups anymore, so I just keep the list. Then I have like a smaller list of ranges, which I call limited ranges here. Actually, don't know if this did anything. Ranges are 187. Limited ranges are 165, so yeah, that did help to get only 1 range per beginning of the range. Then we want to iterate here, so I make a variable combined. While not done, I basically try to combine these ranges. So if there's, for example, so basically go through this sorted list of ranges. I know that they're sorted by the first element in the list, and there's only 1 per first element, a different number. So what will happen is if I always compare the 2 that are next to each other in this list, there's only a few options that can happen. So in this case, these are the 2. In the case of, like, well, I take ranges I and ranges I plus 1. If these are those 2, then what I want to check is the it's bad example, switch it around. So is the last one in my first range bigger than the first one in my last range, or in my second range? Which means then this contains 10 to 16 and this one 14 to 20. So I can just say this is actually one range from 10 to 20. The way I figure out 20 is where I had a bug. Initially, I just picked the number from the second element in the list. But what can happen is this example where I have 1 to 5 and 2 to 7. Oh no, this example where I have 1 to 5 and 2 to 3. So 5 is actually greater than 2, so I want to combine, but 5 is also greater than 3, so I can't restrict my range to 1 to 3. I have to take the maximum of those two last ones. Then once we found one, we pop that out. So we make a result mutable list. We pop this element out, the second one, and then we update the current one or the first one to have the same starting index, the same starting number, and this maximum as the last number. Then I have a new range, or I just in this case deleted this range and I keep the original one. Or in this case, I have a new range, 10 to 20. And then I return that result. So I removed one in try combine. Why is it called try combine? Because maybe there's none. So if try combine doesn't find any, doesn't return here, I just return the original one, which means the list was not made any shorter, which means a new combined is the same size as it was before I tried to combine it, and then I know that I'm done, all the ranges are distinct, and I'm done. Otherwise, I just update combined and try to combine further. So after I combined everything, it's fairly easy. I can just get for each, okay, I don't need this anymore. For each range, I can take the distance. So 3 to 5 is one example, has 3, 4, and 5, which are 3 elements. So I can see by calculating 5 minus 3 and then plus 1, because the ranges are inclusive, I get the right number. Maybe this is clearer. So we're doing here last minus first plus 1 for each of the int ranges. And then I sum them up. And then I get the answer for part 2. So that's it for day 5. Enjoy the rest of your day.